Okay, so hello everyone. Today in this video we're gonna study about uniform circular motion acceleration. Okay, so first of all remember the acceleration is always toward mean position, and whenever the acceleration is toward mean position, that will be negative acceleration because it is applying towards the, we can say, at the opposite side. Acceleration at mean position is negative. Okay, it's negative. Now the acceleration of shadow. We know that the acceleration of the shadow is equal to the x component of the particle acceleration. Okay, and the velocity was equal to the y component, so acceleration is equal to the equal x component. Acceleration is equal to the x component of particle acceleration. We will write it aq, which is acceleration of a shadow, will be equal to minus acceleration of a particle x component. Okay, aq will be minus ap cos theta. I told you acceleration will be x component is equal to cos theta. So now here, as I we denote ap acceleration is equal to r omega square. R omega square. So here we have aq, which is equal to minus r omega square cos theta. ठीक है? And here we can say we have learned कि r cos theta is equal to x. Okay, we have learned previous in the first video. Now here we have what? Now here we have mm, yes, as a q will be equal to minus x omega square. Why I put x? So because as I told you r cos theta is equal to x, so it will be minus x omega square. So now this is the acceleration of a shadow in the uniform circular motion. Since the motion is in the uniform circular, so omega will be constant. As we know, the velocity omega is constant in the uniform circular motion. So omega will be constant. And when the omega is constant, so it will be like A is equal to minus constant, which is omega, and x. So constant and is equal to will be removed, we will put directly sign. So A directly proportional to minus x. Hence it proved that this acceleration is of SHM. Means this becomes the uniform circular motion acceleration. We can say follow the simple harmonic motion. Okay, I hope this is clear. Now let's go with, we can say, minimum and maximum acceleration. So here we have maximum acceleration. So remember at, we can say, extreme position, the acceleration is maximum, and and minimum acceleration is at mean position. Mean position, the acceleration is minimum. Okay, I hope this is clear. Now let me tell you whole sum of this, we can say, displacement, velocity and acceleration in this. Yep, here we have simple harmonic motion, one line. This is what, this is mean position. This is extreme position. This is extreme position. Okay. So now remember at the extreme position we have learned that displacement is zero. Mean position the displacement is maximum. Oh sorry, I got confused here. At the extreme position the displacement is maximum. Mean position the displacement is zero. Same in extreme position the displacement is maximum. If I talk about acceleration, so at mean position the acceleration is zero. We have learned right now. At the extreme the acceleration is maximum, and at the extreme the acceleration is maximum. Last, if you talk about velocity, so at the mean position the velocity is maximum, and at the extreme position the velocity is minimum. Same at the extreme position the velocity is minimum. Let me give you another concept too. At the mean position the kinetic energy is maximum. At the velocity is maximum, so kinetic energy will be also maximum because kinetic energy and velocity are directly proportional to each other. At the we can say extreme position the kinetic energy is zero. Kinetic energy is zero. Last, at the mean position the potential energy is zero. Kinetic energy is maximum. Oh sorry, potential energy is maximum at extreme position. As you know, potential energy and kinetic energy are inversely proportional. So at the extreme position, the kinetic energy is zero, potential energy is maximum. At the mean position, the kinetic energy is maximum, so potential energy is zero. So I hope the concept of the acceleration and uniform circular motion is clear. If you have any confusion from this topic of uniform circular motion, you may ask in the chat box. So from tomorrow we will start the motion under elastic restoring force. Till that, bye bye.